know how to simplify any one fraction by looking for factors of both the numerator and the denominator to divide through by, using the principle of equivalent fractions. Now you can move on to simplifying equations. Look at the following statement. Any numerator can be simplified by any denominator. This is a rule you should remember. Let's have a look at an example of an equation. Say we have 2/8 times by 1/4. Now it would be simply straightforward to just times the numerators through and times the denominators through. But just to show you how simplification works for a process like this, any numerator can be simplified by any denominator. So this numerator, for example 2, I can simplify it by this denominator 8 or by this denominator 4. So in other words, I can look for parallels or I can look for diagonals. So if I was to look for parallels here between the 2 and the 8, I could divide through by 2 because both 2 and 8 are multiples of 2. So 2 divided by 2 gives me 1 and 8 divided by 2 gives me 4. And then that, and now I can just work it out really simply. But also another method I could have used was to look for diagonals. And I could have divided this by 2 because 4 is also a multiple of 2. So now I would get 2 divided by 2 is 1/8 times by 1. 4 divided by 2 is 8. No, 4 divided by 2 is 2, sorry. And then I could just work that out, 1/16. Okay, so look for parallels or diagonals. In this example, I can't simplify this fraction using parallels because 3 and 2 do not have any common factors. I can't do it for 8/27 either. So now I would look for parallels. So 3 and 27. Yes, both 3 and 27 are multiples of 3, so I can divide through by 3. What about 2 and 8? Yes, both 2 and 8 are multiples of 2, so I can divide through by 2. So 3 times 3 gives me 1, and 2 times 2 gives me 1. Times 8 divided by 2 is 4, and 27 divided by 3 is 9. These two equations are equivalent to each other, but this is the simplified version. So now I can just work it out, 4/9. This saved me a lot of the calculation of just moving through the normal process. So 3 times 8 is 24, then 27 times 2 is 54. Now I have to simplify it, so I divide through by 2, and that gives me 12, and then 27, and then I divide through again by, I can divide by 3, and then that gives me 4/9 finally. So this saved me a lot of time. A key thing to mention here, you can only look for diagonals when the sign, when you are multiplying or dividing. So multiplying or dividing, you can look for parallels or you can look for diagonals. But if you are adding or subtracting the fractions, you can only look for parallels, not diagonals. Following equation, I can look for both parallels and diagonals because the sign is a division. So I use the Gcse method. I keep this fraction, I change this symbol, and I flip this fraction. So it becomes 16/21. Now I look for diagonals because I have to reach the multiplication stage to look for diagonals. So both 7 and 21 are factors of 7, so I can divide them through by 7. And both 4 and 16 are multiples of 4, so I can divide through by 4. So that is equivalent to 7 divided by 7 is 1, 4 divided by 4 is 1, times by 16 divided by 4 is 4, 21 divided by 7 is 3. Now just multiply through 4/3. However, if I had 7/4 plus 16/21, I can't look for diagonals and simplify it. That does not work. I can only look for parallels, and since none exist here, I just have to go along and move to the next step of finding a common denominator, a lowest common denominator.